Alright, we're solving for a variable in a linear relation. This seems like deja vu because we've been doing this for a while now, right? We've been solving for variables in a linear equation for a while now. But we're going to continue to keep doing it. Hopefully it'll sink in after today's lesson. Kevin, do you mind just erasing that? Thanks. So our goal is to use inverse operations to solve for a variable in a linear relation. The first example we have is a bike repair. There's two kids working on bikes at a store, I presume. They get $2 to install a tire and $5 to install gears. The max is $100 that they'll get paid per week. So the question says, which combinations of tire and gear repair will earn $100 exactly? So the first step is we need to define our variables. T we're going to use for the number of tire installations, and G we'll use for the number of gear installations. Then we develop this equation. This is all of us on our own here. We're calculating the money on the left-hand side. So we get $2 times the number of tire installations, plus $5 times the number of gear installations, and we know we can have a maximum of $100. Okay, so we developed that equation. That question asks which combinations of tire. So in order to find a combination, who can tell me what would be one way to find a combination of number of tire installations and number of gear installations? It's one thing I can do, Mark.
You could subtract the gears and then find the maximum tires that you could do with 100.
Yeah, so you're saying if we actually substitute 0 for gears,
Yeah.
you said subtract, but I know what you mean. You're saying if there's no gear installations, you could figure out how many tire installations there are. So let's do that. So Mark suggested let's subject 0 for gear installations. So we have 2t is equal to 100. So t is equal to 50. So if you had no gear installations, you'd have to have 50 tire installations to make exactly $100. What's another way? Yeah.
You can do the same thing, sub 0 in for t.
Okay, yeah, we could do that, and then we get 20 gear installations. Good, so let's do that. Okay. It's another combination, Michael.
Sure, you can make it only one variable and then do like t plus 3, then again 5. So you don't have the g anymore.
Sorry, I'm not sure what you mean. Make it one variable. Yeah, so exactly. You just sub in a value for t or g, right? You can make up any value, right? So let's say we did 5 tire installations. Okay, so we're going to say t is equal to 5. So now we have 2 times 5 plus 5 times g is equal to 100. So we have 5g is equal to 90. G is going to be equal to 18. Okay, so that's the idea. You can find out really any combination by subbing one value in for one of the variables and figuring out what the other variable is. Okay? So 5 tire installations and 18 gear installations will earn exactly $100. So there's several different ways, of course, we can do it. Alright, let's look at example number 2. So they show us all sorts of different ways. You could also graph this, right? And then we could just look on one axis. So if we had the tire installations on one axis, we could look at 5 and then go up and then see how many gear installations would have to be with tire installations. Of course, we get a linear line if we were to graph that, right? T being one axis, G being the other. All right, let's look at example 2. Okay, this question says, solve for y in terms of x. What's that mean, Nicholas?
So when we substitute a value for x, what is y?
You're right, but we don't have a value for x to substitute. right now. So what does it mean? Solve for y in terms of x. Josh?
Assume that x is 0, so therefore you just said.
No, can't assume x is 0, no. Solve for y in terms of x. Austin?
That means y is something x.
Yes. Y is something x, but basically what it's asking for, when we say solve for y, what that means is y equals, right? It wants us to have y on the left-hand side of an equality equaling some value of x. Okay? That's what it means, solve for y in terms of x. It wants us to end up with something like this, y equals something something x. Okay? So in other words, it's saying isolate for y even with the x variable involved. Okay? So we're trying to isolate for y. It says solve for y, so we want to find out what y is. So remember, we need to do reverse operations or kind of moving stuff away from y is what I like to think of it. So I'm going to leave the 1/5 y. It's attached to the y. I can't move it readily. And then I'm going to move everything away. So we have, this becomes minus 2/3 x. Okay? Next step is I need to get y on its own. So in order to do that, I need to multiply by 5. Because then these 5s will cancel out and I'll just be left with y. That's what I want. So then I also need to multiply everything else by 5. Which gives me 10 minus 10 over 3 x. Okay, so there's my final answer.
Sure.
Yep.
This is 10 over 15.
No, because the 5 is on the numerator. So it's 2 times 5 is 10 and 3 times 1 is 3.
Oh, yeah, never mind.
Okay. Any other questions with that one? I could have multiplied everything by a common denominator of 15 at the beginning also. Would have got the same answer. Okay, but you need to be comfortable using fractions. So get in the habit of not always having to convert it to eliminate the fraction. Let me just show you that though, if we did. So let's put it down here. Say we wanted to eliminate the fractions. So you need to know this formula before you can answer this question. Okay, it's a finance formula for simple interest.